All right, so example 2 is very similar to our last example. Obviously, we have trig now instead of, I like how I broke my brain there, a polynomial, but we're dealing with an algebraic definition of a function. We're being asked to find intervals of the concave up and concave down portions of our function and points of inflection. So we know we need a second derivative. Little bit different too, we've also been given a first derivative as opposed to the second, but we know if we take the derivative of a first derivative, we're at our second derivative. All right. We also have a little bit of nastiness here. We need to recognize that this sine of x squared is actually a chain rule question, right? We need to deal with that power first because the square is actually outside of everything, even though we write it silly as mathematicians. So 2, leave the inside alone to the first power, times the derivative of the inside, plus the derivative of my second one. The derivative of cosine is negative sine. Boom. Oh, this is exciting. We got some trig equations in our future. So typically, right, last time I just factored, I knew what the zeros were. This time I'm going to do a little bit of work to find my inflection points. I'm going to set this all equal to 0. Or possible inflection points, right? Can't say they are. So we need to know how to solve that particular trig equation. We need to recognize here we have 2 different trig functions running around, sine and cosine. That usually means that one of 2 things are going to happen. Either, 1, we can factor one of them out entirely, so it's not a big deal. We end up with our 2 factors. They both separately have one trig function in them. Or 2, we need trig identities. And I'm always hoping that it is not the latter because I know like one trig identity, and that's the Pythagorean identity. So thankfully here, I see both terms have a sine of x in them. So I'll go ahead and factor that out. So we end up here. Now these are 2 things I can set equal to 0. As I was mentioning in my little rant about things that could happen with our trig functions, both of the factors here have a single trig function, which means they're simple to solve. We can set either sine, that's not what I wanted. Sine of x equal to 0. I'm going to assume that we are only on the interval 0 to 2. Yep, it's missing, but it's in a different version. So, because otherwise we're in trouble. We have an infinite number of things. So, I'll change that in the notes, but we're on the interval 0 to 2 pi. So sine of x is equal to 0 if x is equal to 0, pi, or of course 2 pi. All right, and then we also need to solve 2 cosine of x is equal, or minus 1 is equal to 0. With a little bit of isolation, we get the same thing we've seen a bunch of times in these notes in section 5 in our module 9. I'm getting mad that it's not writing. We get out cosine of x is equal to positive 1/2. And not because I have any knowledge of the unit circle, but because we've done this problem as part of 2 other problems, I know the answers are pi over 3 and 5 pi over 3. All right, so I've got a lot of different things going on here for my beautiful number line, right? So let's go ahead and make up that number line. All right, 0. We don't really care what happens after 0, so I guess I could just be like, don't need the arrow. I'm on the interval 0 to 2 pi. In fact, I don't need this arrow either because I'm going to stop at 2 pi. All right, I like this. We have pi in the middle, and then pi over 3 is not halfway. And 5 pi over 3 is the same. The spacing really doesn't matter. I just felt like showing off because I knew something. All right, so there we go. We need to figure out all of these different things. Gross. All right, so let's think. We have to go back to, now we're on the G double prime, right? So we need to think about this beautiful thing or that thing up at the top. All right, I'm going to just do pi over 2 first because that seems easy. Okay, my brain hurts. I'm already sad that I have to plug this in. All right, so sine of pi over 2 is 1. And then we'll have a 2. Cosine of pi over 2 is 0 minus 1. So this will be 1 times a negative 1. This is negative. So this whole section is concave down. Perfection. Now, my guess is that we're just going to go back and forth, but I don't know that for sure, so I'm really, really sad, but I'm going to have to plug in some more stuff. I still think 3 pi over 2 is going to be the easiest thing to work with. It's another quadrantal angle, right? Any of those things that are on the actual axes of our unit circle are the easiest to work with. So now our sine is -1. Cosine is still 0. But now we have a -1 times a -1, which is a +1. That doesn't look like positive. There you go. So this section is positive. I was going to use blue because I've been using that for concave up and concave down. All right, so this confirms pi is a point of inflection. Oof, inflection point. Yay. All right, and I should probably put some stuff here so we kind of know what we were plugging in. I'll be good about it. So that way somebody who looks at this knows what the heck all those scribbles are on the side. Okay, I guess we got to do some more. Let's try pi over 4. I'm so not looking forward to it. That's root 2 over 2. Times 2 root 2 over 2 minus 1. So the real question is root 2 bigger than 1? Which it is. So we're going to have a positive times a positive. This is positive. That's all I really need, right? So we are getting some switching back and forth here. So we got another positive. This is another concave up section. And we have another inflection point. I'm going to just do that because I'm very lazy. Okay. Now, my guess is if we do the last one, we're going to end up in the same situation as before. But if you want it to be good about this test, let's try 3 pi over 4. Or actually, we have the cutoff at 2 pi, but that cutoff at 2 pi is not actually when we're switching signs, is it? Oh, it is because of the sign. Sheesh kebabs. Yeah, we have to actually test 3 pi. I'm sad. All right, so now I'm in quadrant 4, which means this is a negative root 2 over 2. Cosine is still positive. So we end up with a negative times a positive, which is, come on, negative. I forgot to put in my little labels. This is pi over 4, and this was 3 pi over 4. So we are negative again, as expected. We didn't expect anything different to happen. Math is all about patterns, so when things start happening a certain way, they probably continue that way. All right, so we got our inflection points. So I am going to be lazy here and not write in my answers. In fact, I'll probably, let me make sure this guy didn't make any of the errors he made last time. Okay, he didn't. There were errors in the last key. If you wanted to, you could put in all of the lovely language to go along with this, which I'm just going to like shove over in this corner and be like, yeah, there it is. It's concave up on those intervals, it's concave down on those intervals, and those are our points of inflection, all of which we've labeled and our beautiful number line. So I don't want to write it all out, and I'm out of space.